Hello everyone, my name is Sheikh Amir Farouk and welcome to the visual abstract for our paper titled Machine Learning Assisted Fracture Prediction Integrating Synthetic and Experimental Data for Quasi-Static Notch Failure Analysis. This work presents a machine learning assisted approach for fracture prediction, combining synthetic and experimental data to analyze the quasi-static notch failures in polycarbonate specimen. Well, what was the motivation of this problem? Polycarbonate is widely used in high-impact applications, the tough transparent polymer used in many engineering structures as well. However, when there are geometric discontinuities such as nodes, predicting fracture becomes very complex. Traditional methods require extensive experimental testing, which is often costly and time-consuming. So the methodology, our objective was to develop a framework that reduces this dependency by integrating synthetic data. We generated this synthetic data by the physics-based simulation with experimental data to train robust machine learning models. First, we performed quasi-static tensile test on U-notched polycarbonate specimen on 11 geometries. Second, we used the TCD, point method, theory of critical distances, and within an automated PYMAPDL finite element framework to generate 32 synthetic data points. Finally, we combine these synthetic data points with experimental data to train an XGBoost regression model aiming to predict fracture loads across various node geometries. Overall, we had 6 combinations and those were evaluated, compared for the results as well. The 6 combinations were experimental only, 75 experimental, 25 synthetic, and so on. And also we had a full data set combining all these data points from synthetic and experimental data sets. So the XGBoost model trained on both experimental and synthetic datasets produced highly accurate fracture predictions. As you can see from the plot given, they are very close to the ideal line within the 5% error margin. The machine learning data model on a full dataset combining both experimental and synthetic data achieved the highest performance. As you can see, it yielded only the mean absolute percentage error of 1.18% and R square was 0.757, significantly outperforming other models. But in conclusion, this study demonstrates that the physics-based synthetic data can successfully augment experimental data. This hybrid approach enhances the robustness of machine learning predictions for fracture analysis, offering a practical route to reduce the cost and time associated with extensive experimental testing. Thank you so much. Happy reading.